Hello, and in this video we're going to be looking at the introduction to inverse functions. Functions are going to be made up of terms that have operations between them or over them or combined with those operations there will be terms, but we're going to be looking at how inverse operations work. So let's just take an example. A simple example would be addition. Its inverse would be subtraction. So the inverse of addition would be subtraction. The inverse of subtraction would be addition. The inverse of multiplication is division. And the inverse of division is multiplication. There's also inverses in like roots. So a cube root, that's this kind of thing, has an inverse that's a cube. So something cubed. So a root can also have an inverse, and they go back and forth as well. So a cubed is the inverse of a cube root, and a cube root is the inverse of a cube. So as I said, we're looking at inverse functions that include these operations. So what it's going to be is it's a function that contains operations that undo the operations of the function. So the inverse functions, its operations are going to undo the operations of the actual function. So an example of that would be something like if we had a function f of x equals x plus 7. What we're doing here is we're adding 7 to the term, to the value of x. So we would want to undo that. So the inverse function, which we would denote with a little -1 here, so inverse has a little -1, the inverse of the function would be x minus 7. So we would be doing a subtraction to the, we use the opposite operation to undo what we did in the first function. First we added 7 to the x, now we're going to subtract the 7. Another example would be something like a division problem. So if I had a function g of x equals x divided by 3, then our inverse function, with a little -1, g inverse of x, would be x times 3. We would write 3 times x. So we have division here, and we have multiplication here. So we're using the opposite or the inverse operation that we discussed up above here. So if we see multiplication of one function, the inverse function should have division. So let's take a look at a specific example where we have multiple operations happening here. So in this function we have g of x equals 3x plus 4. We're looking at finding its inverse. Well, if we were to take the input, so in the function, so let's look at one function value. If we input 2, it's going to take 2 times 3. So we're going to multiply by 3 first. So we're going to multiply by 3. And we'll get 6. Then we're going to add 4. And we'll get 10. So our output for an input of 2 is output of 10. So our inverse function, we're going to want to take 10 and go backwards. So we're going to want to take 10 and go backwards. So inverse, we want to go this way. So in an inverse, we want to input 10 So we want to do the opposite thing. So we're going to take and subtract 4, so we get 6, and then we're going to divide by 3 and get 2. So our output is matching our input from our original function. Now that actually, we could write an equation for that. So in this case, our G inverse function is going to first subtract 4. So we're going to take our x value and subtract 4. And then we're going to divide that number by 3. So we're going to divide everything, that number, by 3. So this would be my inverse function for that function g of x equals 3x plus 4. We want to follow these arrows back, and we want to create a function that subtracts 4 and then divides by 3. All right, some information about the inverse. So the inverse function, at any point on the graph or on the function, what's going to happen is that it gets reversed. So on the function, when you have an xy point, on the inverse, you're going to have a yx point. So the function reverses the point on the graph and in the function, because we're reversing what we do here. Okay, what that means is that since we're reversing, this y value and this x value are the same. So x becomes y and y becomes x. And we're going to do that algebraically here in a minute to show you how to do a function that way. But that means that the domain of the function, the domain of f, becomes the range of the inverse. And the range of the inverse, range of f becomes the domain of the inverse. So the domain and range actually swap when we do the inverse. The domain and range swap. So that means if the domain is all real numbers, then the range of the inverse is going to be all real numbers. If the domain of the function is greater than 0, x is greater than 0, then the range of the inverse is going to be x, or actually it's going to be the inverse, it's going to be f inverse of x is going to be greater than or equal to 0. All right, so here's how we're going to do that since we're swapping. So we're going to use that method to help us to be able to do this algebraically. So we're going to do this algebraically using this method of swapping. All right, so the first step in this process is to replace function notation with y. So my first step here is to write, on this problem, is to write y equals x cubed minus 4. That's the first step, is to replace this f of x with y. My second step here in finding the inverse is to swap x and y. So this function here becomes x equals y cubed minus 4. My third step here is to solve for y. So that means in this process I would add 4 to both sides. So I'd add 4 here, add 4 here. So I'm going to get x plus 4 equals y cubed. And then I'm going to need to take the cube root of both sides to get rid of that cube. So I'm going to end up with y equals the cube root of x plus 4. Okay, and then my third step is to my fourth step is just to rewrite. So write with inverse notation. So we're going to write it with inverse notation. So basically this y is going to become In this case, since we were doing f of x, this y is going to become f inverse of x equals the cube root of x plus 4. Okay, and if I think about this, what was I doing to the original function? I was cubing it, then subtracting 4. So in this function, I'm doing the opposite. I'm adding 4 and then taking the cube root. So it seems to be the inverse. All right, and here's my final example in this section. We're going to find the inverse of this function, g of x equals 1 over x plus 6. So we're going to follow the same 4 steps. So remember, the first step is to replace function notation, replace g of x with y. So it's going to be y equals 1 over x plus 6. Okay, that's my first step. Replace g of x with y. Second step is to swap x and y. So that's going to become x equals 1 over y plus 6. Third step is to solve for y. So in doing that, we need to multiply, since we have a fraction here, my first step here would be to multiply through by the denominator. So I need to multiply both sides by y plus 6. Y plus 6. So this side over here reduces out. I'm going to be left with 1 equals y plus 6 times x. Okay. Then there's a couple things I could do here. I could divide by x first, or I could distribute. So you'll get equivalent answers, but they'll look a little bit different on this one. So we're still solving for y. So first of all, if I divide by x, I'm going to get, I divide by x, I divide by x. I get y plus 6 equals 1 over x. And then I subtract 6, and I get y equals 1 over x minus 6. And then so if I do it that way, that's what it looks like. If I decide first to distribute, so if I take this thing here and I distribute the x, I'm going to get y times x plus 6x equals 1. I'm going to move my 6x, subtract my 6x, and I'm going to get y times x equals 1 minus 6x, and then I'm going to divide by x. I divide every term by x, or I just divide the whole thing by x. If I divide every term by x, I get the same answer. If I just write it as dividing by x, I'm going to get y equals 1 minus 6x over x. So both of these are equivalent, and they're the same thing. We could separate this one out and reduce, and it would be this. So my f, well, let's look at our function up here. Our g inverse can either be 1 over x minus 6, or it could be 1 minus 6x over x. So either one of those is my inverse. So that's the process we go through. I'm sorry I didn't write down step number 4 here, which was what I just did right here. I replaced y with inverse notation. Okay, and that's it.